Okay, chapter 8 is all about matrices, and a matrix is basically a rectangular array of terms called elements. And it looks like this. You have your brackets, and then inside there you have different numbers or letters, your elements. To describe the size of a matrix, we give its dimensions, which is your number of rows by your columns. And I remember that because it's like RC Cola. You do the rows first and then the columns. So here there's 2 rows and 3 columns, so that's a 2 by 3 matrix. We do have some special matrices. If it's just got 1 row, that's called a row matrix. Similarly, if it has 1 column, that's a column matrix. And a square matrix is if it's the same number of rows as columns. So like 2 by 2, 3 by 3, 4 by 4, so forth. You're going to use a matrix in this particular instance and some other instances to represent data. So go ahead and pause this and try to create your own matrix. Okay, your matrix should look something like this. At the very least, it should be a 3 by 3 matrix. Now I did it where each month was a row. So like my first month was June, my second month was July, my second row was July, and my third row was August. And then each column represented your types of phones, so your iPhone, your HTC, and your BlackBerry. If you did it the other way, that would be fine as well. But because you could have represented this either way, your matrix does need these labels so that I know which row, well, what each row represents and what each column represents. So when I see the 65 here, I know that that was July. You sold 65 HTCs, or sorry, received 65 HTCs versus another month and another type of phone. Right, 2 matrices are equal if and only if they have the same dimensions. So first off, in this case, this one is 2 by 1, 2 rows, 1 column. This is also 2 rows, 1 column. So they have the same dimensions and they are identical element by element. So if I'm trying to figure out what numbers my x and y needed to be in order for these to be considered identical, then that would mean that y has to equal 4x and y minus 3 would equal 2x plus 1. And that's just like a system of equations that you could solve with substitution, elimination, graphing. So go ahead and pause this again. Use one of those methods to solve this. I decided to use substitution to solve it, so I plugged the 4x into the y, solved it, I got x equals 2, plugged that back in, I got that y equals 8, so my matrix is actually 8, 5, and I would get that by putting 8 here would be 8, or 4 times 2, if I plugged my x in, would be 8. Down here, 8 minus 3 is 5, or 2 times 2 plus 1 is 5. So it wouldn't matter which matrix you plugged it back in, because they're equal, you should get the same thing. To add or subtract 2 matrices, first off, they have to have the same dimensions, and then you're just adding or subtracting their corresponding elements. So for A plus B, I'm going to do negative 7 plus 6, 4 plus 10, 5 plus 8, 0 plus negative 9, 3 plus negative 2, and negative 1 plus 5, so that I get negative 1, 14, 13, negative 9, 1, and 4. So that is A plus B. Go ahead and pause this. I want you to do A minus B and 3A. Go ahead and check your answers with the ones that I have down there and make sure you're able to get that. Okay, you can also multiply matrices. When you multiply matrices, your number of columns in the first row must equal the number of rows in the second row. So what that means is, let's say I have a 2 by 3 matrix and I want to multiply it by a 3 by 2 matrix. So this is 2 by 3, this is 3 by 2. basically the columns of the first one, so the second number, and the rows of the second one, so that first number, have to be the same. The 3 and the 3 are the same, so I could multiply those, and my answer is actually going to be with the outside numbers. So a 2 by 2. If you have a 2 by 3 and a 2 by 3, when I look at the middle numbers, so columns of the first one, rows of the second ones, those are not equal, so that would not be possible. So let's look at actually how to multiply these. You're going to use these matrices to find each product. So let's start with AB. So when I do A times B, first off, I need to check my dimensions. So this is 2 by 2, this is 2 by 3. Their middle numbers are the same, so I can multiply them, and I actually know that my answer is going to be 2 by 3. When I do this, the way I multiply it is, I'm going to, say for this first row, first column, so this first element here, I'm going to use this first row and this first column. And I'm going to start with 7 times 3, and then 0 times 3, and I will be adding those. So my answer for that first one is going to be 21. For the first row, second column, I still use the first row, but this time I use the second column. 7 times negative 3 is a negative 21. 0 times 4 is 0, so I end up with negative 21. First row, third column, I use the first row. In the third column, 7 times 6 is 42. 0 times negative 2 is 0, so I get 42. Go ahead and pause it and try it on your own for the second row. Okay, so when I work on the second row, I'll be using the second row here, and then for the first element, I'll use the first column. 5 times 3 is 15, and then 3 times 5 is also 15, so I have plus 15, which gives me 30. When I move on to the second column, still in that second row, 5 times negative 3 is a negative 15, plus 3 times 4 is 12. So when I add those, I get negative 3. And then when I'm going for the second row, third column, 5 times 6 is 30, plus 3 times negative 2 is negative 6. So I end up with 24. This matrix here is my answer when I multiply A times B. I want you to now do BA, AC, and BC if they're possible. When you do B times A, you're doing a 2 by 3 matrix times a 2 by 2 matrix. The middle numbers, columns of the first one, rows of the second ones, are not the same, so this is simply not possible. When you do A times C, you're doing a 2 by 2 times a 2 by 3. Middle numbers match, so you can multiply them, and your answer should be 42, negative 7, 28, 36, negative 11, 17. Finally, when you do B times C, which is a 2 by 3 times a 2 by 3, middle numbers don't match, so that one is not possible.